as a desktop person who was curious about automating things, I wrote a lot of scripts. I sort of had them set to trigger at certain times a day and things like that. And I've set up a few systems that, from my point of view, they work beautifully. But as soon as the GIS person disappears, or as soon as you turn your back and think about something else, things start falling apart.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is John Bryant, and he is heavily involved in the open source geospatial world. He's also the founder of a company called Mammoth Geospatial, and he has agreed to come along on the show today and talk a little bit about Postgres. So Postgres is an open source relational database that we should be perhaps thinking about including in our stack if we haven't already. So John's going to walk us through what it is, where it came from, and hopefully encourage people to get out there and try it if they haven't already. So this is a slightly different concept from what I've been doing up until now with the Mapscaping podcast. So I am really interested to hear your feedback on this, if there's something you'd like to hear more about, if we should just be focusing on tools, like in this case, this database, and talking about those, if that's something that's helpful for you, or if you'd like to stick with hearing about companies and a little bit more sort of thought leadership in the geospatial world. Either way, I would love to hear from you. Just before we get started with the interview today, I want to mention that we have a new sponsor. OpenCageData has agreed to sponsor several episodes of the Mapscaping podcast, and I'm truly grateful for this. Ed, the founder of the company, he's actually been on the show a couple of times before. The first time he was talking about geocoding, and he used this example of the geocoding was the way of translating between humans and machines, and I found the whole subject actually really, really fascinating. So I'd encourage you to go and check that out. And the second time he was on, he was talking about his work with GeoMob. And GeoMob is a really informal geospatial meetup, which Ed puts a ton of work into. And by supporting the podcast, I guess it's just another thing he's doing for the geospatial community, and it's fantastic. So Ed's company, OpenCageData, is a geocoder. They have a free trial version, so you can test it out, you can try before you buy, and Ed offers incredible support. So I would highly recommend you check them out if you have any geocoding needs. Okay, let's get into the interview. Hi, John. Welcome to the podcast. Thanks so much for taking the time to do this interview with me. And this is, in fact, interview number 2. The first one, we had a few technical problems, so I really hope we can get through the whole interview this time. That would be amazing. I guess the reason I invited you on the show was because that you're heavily involved in the open source geospatial world. You are the founder of a company called Mammoth Geospatial. So I guess what I'm getting at here is you have a real solid background in geospatial and a really good technical understanding from a practitioner's viewpoint of how things work and how things fit together. So I've invited you along the show today, and we're going to be talking about PostGIS, Postgres, so relational databases and how they work in the geospatial world, and why people might want to invest time into using and understanding them. But before we dive into all that, can you just walk us through your journey into geospatial? How did you get to where you are today?
Sure, yeah. Thanks, Daniel. So my background is I started my career as a desktop GIS analyst in small organizations, and did that for several years, mostly in Canada, also a little bit in Australia and in South America, kind of moving around a lot. Yeah, and then at some point I discovered open source geospatial, and it opened up a whole new world for me. So I kind of dived deep into that, and over the last 8 or 9 years or so, I've been getting really, really into open source geospatial stuff, mostly as a user in the beginning, and then getting a bit more into a little bit of programming and then system building and integration. And in the last few years, I've been heavily involved here in Australia, where I live now, in organizing FOSS4G and State of the Map conferences. So here in Australia, like I say, and also in New Zealand and Fiji.
So firstly, let me say a big thank you on behalf of the geospatial community. I understand that organizing that kind of community event is a big deal and must take a lot of time and effort. So really appreciate that. Thank you.
No problem. I mean, I guess I want to also pay my gratitude to all the people that make this possible, and I suppose that community organizing is one way that I can do that.
Well, again, like I say, we really appreciate it. Us that are on the other side of that think it's amazing. Thanks. Today, we're going to be talking about relational databases, and we're going to be talking specifically about Postgres, PostGIS, and perhaps we should start off by explaining what it is.
Sure. So PostgreSQL is a relational database management system. It's open source. It's considered to be best of breed and enterprise grade, but it doesn't itself have much or any geospatial functionality built into it. So PostGIS, what it does is it's an extension that you can run alongside, like it's built to plug into PostgreSQL, and it allows you to do spatial operations, store your data, store geometries, build spatial indexes, and so on, so that you can actually use it as quite a full, functional, beautiful piece of equipment in your stack.
So I guess before we really get into this, I think we should sort of talk a little bit about why people might want to use a relational database like this instead of flat files. Can we talk a little bit about some of the advantages there?
I mean, from my point of view, like I think about my experience as a GIS person coming from that kind of background. So for the first large part of my career, most of the systems I was using and building were based on folders full of shapefiles or map info tab files or what have you. And I mean, to be clear and honest, there's no shame in taking that kind of an approach. Like it's a perfectly valid way of managing spatial data, and it works, and it's simple, and it's nice. But I think that one thing you run into with a system like that is you do run up against limitations. Like the shapefile has its own limitations in terms of file size, and column names can only be 10 characters and so on. Security and permissions, archiving, backups, and so on. You can do a lot more with a spatial database than you can with a folder full of shapefiles. And at some point, as the complexity of your system grows, you may find yourself in a situation where you want to dive into that. So I think that it's sort of like you could see it as a natural progression, I suppose. I mean, it certainly was in my experience to start building systems that relied on spatial databases and give you a lot more of that functionality out of the box.
Absolutely, and I agree with everything that you said there. I'd just like to add that I think one of the huge advantages here is that multi-user functionality side of relational databases. As soon as you have lots of different users looking at the same data or wanting to edit the same data at the same time, then relational databases are definitely the way to go.
Absolutely.
I also really like the idea of centralizing data. So I've definitely had some experiences working in companies where everybody has their own shape files, their own copy of data
Right.
on the C drive somewhere, and so then very quickly, okay, well, who's got the most up-to-date data? And if it's in one place, one centralized place where lots of users can access the same data, edit it, update it, maintain it, then that question of who's got the most up-to-date data, it doesn't even need to be asked. The data is there.
You can waste a lot of time chasing up that one sort of canonical version of the data. And I guess that's one of the things about a spatial database is that it enforces, you can enforce, and it enforces upon you some discipline with how you structure your data. And so in some ways that can be kind of a pain, but on the other hand, if you want to have a well-managed database, this is, it's a great way to do it. It's I remember being exposed to this idea of the single point of truth at one point, and it was just like a light bulb when I was like, oh yeah, you don't have to sort of have 6 different people managing data in their C drives, and hopefully you can find it when you need it. It's like you can actually have this central repository that is trusted.
Yeah, absolutely. This is one of the big reasons why people move from flat files to that centralized point of truth to relational databases. So there's lots of amazing things about relational databases, but I'd like to pick on just a few here, and I'd like to start with views. What is the magic of a view? What is a view, and how might I use it?
Yeah, so a view is in a spatial database, in a SQL relational database. A view is basically like you build an expression, you write a SQL statement that takes the data in one or many tables and produces, an output, basically defines that output that you can use as if it were its own table. And so what that means is that if you have a data set, so maybe I'll use the example of caribou collar locations. Suppose you're working in parks and wildlife in North America, and you've got some automatic collar locations that are being updated from an API, and you've got some magical way of pumping them into your database. You've got this this table that's always being updated. If you have this one table, you could actually potentially generate a whole slew of byproducts from that, and define them as views so that if you're in your desktop environment, you can add them all as if they were data sets. So like for example, if you've got these color locations, you can have another view that is like just the latest location points for those caribou. So where were the caribou last time we saw them? Or you could have polygons that are like the ranges of these caribou, or you could have a set of lines that are the actual paths that each caribou has followed on its journey through the tundra, and so on. And if you wanted, you could also like add attributes from another table that has some kind of spatial relationship with them. So you could say, well, during this time, this caribou was in the Yukon, and during this time it was in Alaska. And you can define all this stuff using, like I said, SQL queries, and not have to sort of manually update those outputs every time you have a new set of inputs that you want to put in. It just happens on the fly.
And I think one of the beautiful things about this is that it's documented in the database. I can go into the database and I can see exactly how this filter or this join or this view was formed, what it's based on, what the underlying tables are, how it's been put together. And so that's amazing to have it on that side. But in terms of a user using this, it's just another layer in the database. It's just another layer they can drag into QGIS or ArcGIS or something similar, and they don't have to see the complexity in the background. And I think that's just amazing.
That's right. Yeah. So I mean, if you're the GIS person in an organization, you don't have to be the only person that uses that GIS, but you could potentially be the only person that has to understand all the relationships between the data. You can publish those views as services to all your users who may or may not even be using GIS. They could be using an intranet or whatever.
Absolutely. I'd like to stay with the caribou example now because it's a fantastic example. And I'd like to talk about triggers. Can you describe for us what a trigger is and how we might use it?
Sure. Yeah. Well, a trigger is basically a trigger is a bit of logic that happens when a database event takes place. So if you have somebody goes and edits the data manually, or maybe you've got, like I mentioned before, these caribou color locations being pumped automatically in your database. You can set it so that as a new row is entered into the database, a certain function is executed. So that function might just do something basic like add a create date column, a value for a create date column, or it might trigger some other action, like maybe it'll update some other table. Maybe there'll be like another. Maybe there'll be some kind of an output that will tell you how many points this one caribou, or how far this one caribou has traveled, or something like that. But I'm not explaining it very well. But it's like the upshot is, it's like when an event takes place, one of these database events takes place, it can execute your custom function.
I could see this being used in terms of data validation. Like, is this a valid piece of data that's being entered into the database? Yes or no?
Yeah, great point. So, like using the caribou example, is this point? These are based on GPS locations, which can be a bit fuzzy sometimes, a bit noisy. So, is your caribou location in the middle of the Pacific Ocean, or is it actually somewhere you expect it to be? And if it's in the wrong kind of place, it could discard it, reject it, or what have you.
Personally, I think triggers are really amazing. I love the idea that this functionality is baked into Postgres, PostGIS. It's in one centralized place. It's documented in there, so anyone can go and have a look at it and understand what's happening and why it's being executed each time this database event takes place. But another thing I really like about it is that it can replace this can be quite complex network of scripts that you might build if you didn't understand how to use triggers. So in my experience, I've seen people do this that have been really excited about, let's say, Python as a programming language. And so that's the tool. They've needed to solve a problem. They've gone to the tool chest, got out the tool, and then started creating these Python scripts all over the place that are operating in different places at different times on different data sets. And it's really difficult to maintain that kind of web, at least in my experience. And I see triggers as being a much more sort of elegant way of doing this.
Yeah, in so many cases. So I mean, I can relate to that kind of idea 100%, because I mean that was my journey. as a desktop person who was curious about automating things, I wrote a lot of scripts. I sort of had them set to trigger at certain times of day and things like that. And I've set up a few systems that, from my point of view, they work beautifully. But as soon as the GIS person disappears, or as soon as you turn your back and think about something else, things start falling apart. And these systems that rely on a lot of scripts and so on, they can work beautifully, but they can also be somewhat fragile. And I think spatial database does for you is it allows you to build some of that logic into the data store itself, where it's very well managed. And I guess it's that single point of truth concept.
And again, I just want to emphasize, just like we did right at the start of this interview, we're not trying to shame people into using relational databases in any way, shape, or form. In the same way we talked about that journey we've both been through with the use of flat files and the sort of evolution over to realizing that a spatial database might be the way forward and we might be able to solve other problems with it. I think triggers the sort of next step for some people anyway in their sort of journey in terms of automation. And I think it's really important to go out and experiment and sort of decide or have those experiences where, oh, okay, this worked really well, this didn't work so well. And scripting is a really important part of that. At least it has been in my journey.
Yeah, and for me too. And yeah, I couldn't agree more. There's no shame in building a system that uses a flat file system. I mean, it's in some ways if you have a simple need, then you need a simple system. And a spatial database is going to be overkill for a lot of use cases.
So when we're talking about triggers just before, we were talking about that idea of documentation. How do you think they fit in terms of creating sort of reproducible workflows? Or maybe a better question would be, where do you think a database is in terms of creating these reproducible workflows? Is it something we should be thinking about, or should we be sort of looking more towards the model builder style of doing things?
Yeah, well, I mean, I think a lot of GIS people can relate to this idea of a reproducible workflow, like especially if you've gone through that process of running 100 different commands to get to your final .shapefile. Like that's and then the next day your customer, your coworker, whoever comes back to you and says, "Oh, we need to do it again, but can we actually change the inputs?" It's like, oh damn. So like the model builder is definitely one way to do it. I've used a lot of FME in my time to do that kind of thing, but in the last several years, I've been finding spatial SQL to be more and more delightful, I guess I could say, in terms of how to create those reproducible workflows. So you can write a SQL query with all those spatial processing steps. Say you want to do a reprojection, you want to buffer something, you want to join it to the count of the number of points that are within your polygon, that sort of thing. You can put all these steps into quite an elegant SQL statement, and you can write comments within your code that will sort of give you some pointers as to what it all means when you come back to it a week later, or 3 months later, or 2 years later.
So SQL is a language in itself, and I think it's one of those things where people, if they're going to learn a new language, they want to know, can I use it other places? Is this something I can only use in Postgres? Is this something I can only use in MS SQL, which is the Windows sort of SQL server? What would you say to those people? Is it worth investing time and energy in learning SQL? Can I use it other places?
Yeah, great question. I mean, I think first thing that comes to mind is like investing in any open source language, say it's Python or JavaScript or what have you. These SQL is used in all kinds of places. So you can use it in PostgreSQL, you can use it in SQL Server, you can use it in Oracle Spatial, you can use it with your SpatialLite file-based databases. It's just kind of usable in all kinds of places. So I think this is an investment. Learning SQL isn't an investment in Postgres. It's an investment in learning a powerful way of querying databases in general. Yeah, and I just think it's very versatile language.
So I personally, I feel like SQL as a language doesn't really get the attention it deserves. And I have the same feeling about relational databases. That for me, they're like the drummer in the band. They're always there. They're a really important part of an enterprise geospatial stack. And why do you think that a language like Python, for example, or R or JavaScript seems to get more attention than SQL?
Yeah, that's a good question. I mean, I suppose Python is you can use Python in a lot more places and a lot more use cases. I think SQL is a fairly focused has fairly focused purpose, like a. But I suppose in some ways that's one of its strengths. It's very it's very designed. It's very engineered to fit that particular use case. It does it well, and so I mean, where Python, I guess, is basically Python's a whole universe. You could go in there and never come back out. But SQL, I think, is a really great way to get from to get your hands on your data quickly.
I completely agree. And I think when we start to talk about enterprise solutions for geospatial, I think it's a really important part of the stack. And I don't think people need to go out there and say, I have to be a programmer in SQL. But I think that basic sort of understanding, like with any programming language in geospatial, it's worth obtaining, it's worth investing in, and it's worth understanding.
Yeah.
So we've talked a lot about Postgres now and the geospatial capabilities of it, why people might want to use it. Can you give us an idea of how do we get started? Because I think whenever you start talking about relational databases and all of a sudden there's an extension that we have to download from somewhere, is this difficult? Like, is it difficult to get started? And if we're looking to get started with this, where should we go?
Yeah, well, I'm not gonna sit here and tell you it's easy. I mean, it took me, I'm not the smartest guy around, but it took me a while to actually get past that first hurdle, which was getting the thing installed. But I think that was a few years ago, and I think we've come a long way since then. It's getting a lot easier to install, whatever platform you have, whether it be Windows or Linux or Mac. There are installers around. There are a lot more blog posts and things around that sort of give you some detailed instructions. So I think the first step is really install it on your local machine, get it up and running, figure out how to load some data, and just start poking around with it. And if you're running QGIS on your desktop, connect QGIS to it, load some data, load some tables into it, and watch it go. Like it's actually quite a beautiful experience. For me, it was like I was blown away by how fast it was, and that was so encouraging that I don't think I ever really looked back.
It's been a while since I have installed PostgreSQL and used it as a database on my own personal machine. So I can't remember exactly what the process looked like, but I remember it being surprisingly easy. So I work in a Windows environment, and I remember it being, you get an executable file from somewhere on the net. I can't remember the exact website, but I'm sure if people Google it, they will find it, run it, and then after it ran, it installed the actual database, and then there was a whole list of extensions that I needed to install.
Yeah.
But this came up in a user-friendly way, and you click the button for PostGIS, and that was installed, and then it was done. And I think you said something really important there, that you don't have to dive in straight away and start writing SQL commands into the database itself. You can just use QGIS and install that. And I think there's some really good plugins out there that could help us
Definitely.
there. And you could, at the start anyway, you can just interact with the database through that QGIS environment. And that would be a great way to get going.
Definitely. So there's one core plugin in particular called DB Manager, and it will actually take care of a lot of this stuff for you. So you can actually go straight from installing your database to connecting to it with DB Manager, and you can actually use DB Manager within the QGIS environment. If that's a familiar environment to you, you can push a shapefile or whatever data set you have into the database, and then you can even start writing SQL queries right in that DB Manager plugin if you like.
Is there any other editors or ways of connecting to the PostGIS database that we should be thinking about?
Many. So, I mean, if you're an ArcGIS desktop user, you can connect to a PostGIS database. I think there are a couple of hoops you need to jump through. I can't remember what they are. It's been a couple years since I did that, but it's certainly possible. FME connects to it very nicely. There are a couple of applications that I use for administering PostGIS databases. One in particular that I'm quite fond of these days is dbeaver. And it actually has like this really nice spatial previewer. So you can do a very simple SQL query like select star from my table. It'll show you all the records that it returns in a grid, but then you can toggle over to spatial view and you can see exactly where your geometries end up on a map of the world or a map of wherever you are. And then another one worth noting is pgadmin. That's a really nice, freely available program for doing this kind of thing.
What you just described there is you can push some data into the database there and you can see it. And for me, that's like the hello world in programming. That's your first interaction. That's when you get to see the data. Yes, it's actually in there. I've done something. And especially if you're using QGIS as an example, just being able to interact with it in that way, I think is a really important way of just getting going.
QGIS actually started its life as a viewer for PostGIS tables. That was the original use case.
Oh, that's really interesting. I did not know that.
Yeah. They were built sort of in parallel alongside. I think before PostGIS even came out with a version 1, there was a QGIS. QGIS's first commit pretty much was a connect to PostGIS.
That's really interesting. I had no clue that was the case. I've just got a couple more questions for you, but before we say goodbye, and one of them is we talked a little bit about this geospatial stack. Perhaps you could describe that for us, what a stack might look like in very simple terms, and how a Postgres database might fit into that stack, just so people have an understanding of what this looks like in the real world.
Yeah, sure. So I guess I personally use the term geospatial stack pretty loosely. Like it could just be whatever array of software that you use and connect to each other. But you could have a really basic. So the most basic stack with PostGIS in mind is you've got your PostGIS database and your QGIS desktop, and they're connected to each other. And there's your stack right there. But also you could insert in between them. You could insert GeoServer or Map Server, which are two very nice open source geospatial server packages. They can take the data from the database and expose it through services, so you can actually consume them. And that means you can use it in QGIS, or you could use it in a web application, or you could use it in any number of things. And that's another part that might fit in the middle. I don't know, what else could you have? I mean, you could actually have some kind of a web application that sits out in front of it, like something that works in a browser built with Leaflet or OpenLayers or Mapbox, that connects to GeoServer or even directly to your PostGIS instance, perhaps. And that can run sort of within your organization or publicly on the web and publish your data. I guess for me, the bottom line is there are many, many configurations and variations on what you can do. And it's sort of gets down to what are you actually trying to do, and who are you trying to reach, who's going to be editing. There's so many variables here, but there's a lot of flexibility in the stack.
And I guess that's exactly what I was hoping that you'd say, is that it's very flexible, and you could start with something very simple. So you can have your QGIS that connects to PostGIS, that can then have something like a GeoServer, for example, connecting to that, and then we can send that data out into the world, expose it through various web services, VFS services, VMS services, and that could be consumed by web clients. So already, and this the magic of all this, for me at least, is that this is all freely available. I could download this tomorrow and get started. And I think this is getting started with something like this is really important for people that are looking to build a career in the geospatial industry, because it exposes you to so many different steps in the process. How does data actually get into the world? And I think that this is really important. So if people have or are willing to spend the time and effort, I think the rewards are definitely there.
And it can be completely overwhelming, but I think you basically just start somewhere and keep going. And after a while, it's not so overwhelming anymore.
Again, I think, there's that initial inertia that you have to get going, and you'll run into problems and you'll solve them and you'll learn and you'll get better, and you'll have new problems and you'll solve those. But hopefully, you'll see a progression there. But what can people do if they get stuck? Where can they go? Is there any communities they can join? Are there places they can ask questions?
Yeah, I mean, this is the thing: is open source is all about communities. So yes, there are many, many places. I mean, if you're Googling your problem, one of the places that you're going to come up with first is the GIS Stack Exchange. But there's the Spatial Community Slack has a lot of specialized channels that focus on things like PostGIS or GeoServer or QGIS. I think in my experience, attending FOSS4G events was a real it was an icebreaker for me. It really helped me sort of get past that being overwhelmed stage, just by talking to people and sort of sharing their enthusiasm for all this stuff. So there's the International FOSS4G, and there's also a whole series of regional FOSS4Gs. Hopefully there's one that's near anybody who's interested in going to them. And also, local meetup groups. Just get together with the people in your community and make friends. And I just feel like sharing enthusiasm is absolutely one of the best ways to get over that hump.
I completely agree. And on that note, I want to say thank you so much for taking the time, for sharing your enthusiasm about this topic. I really appreciate it. I hope that we've managed to help some people out there that are perhaps considering getting into using a relational database. But just before I let you go, where can we go if someone has any questions or want to reach out to you personally? Where can they go to do that?
Well, I'm on Twitter. My handle's Mammoth Mapping. I've got a small geospatial company called Mammoth Geospatial. You can Google it and find me there. Yeah, and I mean, in Oceania, I'm super involved with all the FOSS4G and state of the map stuff here. So got a really great community and love to talk to people in this community about what's going on here as well.
John, thank you so much for your time. I really appreciate it.
All right. Thanks, Daniel.
Just a quick reminder, this podcast is sponsored by OpenCageData, so if you have any geocoding needs, this is the place to go. It's a fantastic company, amazing service, and well worth checking out. And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and a big thanks for everyone who tuned in again this week. Much appreciated. As always, you are more than welcome to reach out to me on social media. You'll find a few useful links in the show notes. Just click those and you'll find me. I would love to hear your feedback on the podcast. If you're looking for an easy way to support the podcast, I would really appreciate your reviews and ratings on iTunes. It makes a huge difference to the amount of people that see the podcast. And also, if you have a friend that you think might find this interesting, please share it with them. That would be much appreciated. Thanks very much. We'll talk again next week. Bye.